Yeah, hi. I'm Tim, and this is Nerd Disco. And yeah, this is my project which I do in my spare time, just out of fun, because I wanted to learn how different web APIs work. So let's start from the beginning. You can see here I have my notebook, and on my notebook I have a browser. And the browser has a lot of awesome APIs, like the Web Audio API. And with the Web Audio API, you can maybe play a song, or you can manipulate audio using filters, or you can analyze it. But let's start from the beginning. First of all, when you start with Web Audio API, you have the HTML audio element, and you can just put any song you like into it. And then you create an audio context, and the audio context is there to get all the functionality of the Web Audio API, which you want. And then you create an analyzer node, which is there to analyze the audio. And you can specify the FFT size, but it doesn't matter what it means. And then you could create an array, which you can use to save the frequency data from the analyzer. And as you can see, I'm using the frequency bin count, and this is half the size of the FFT size. So if I specify an FFT size of 512, I have an array of 256 values in my array. So yeah, the next thing is we get a reference to the audio element itself, and use this reference to create an audio source. And we connect this audio source with the analyzer, and the analyzer with the destination. And the destination might be some speakers. So what we have here, we have the audio element. We put the analyzer in between, and every time we start audio with the element, it gets through the analyzer and then delivered to the speakers. So we get the data of the currently played audio. And when we call the getByteFrequency data function, we get a lot of frequencies put into the array we defined earlier. And the frequencies, if you visualize it, can look like this. You have something from 0 Hz to 22,000 Hz. And these are a lot of values. It's really hard to understand what they are doing. So I was looking in the internet and found a group of people that created some ranges, and those seven ranges specify different frequencies, from low frequencies like a bass drum or something like this, or mid frequencies, which are maybe a guitar or something, and super high frequencies like ooh. So you get an idea of what the frequency data is. And instead of using all those values, I only use the 7 ranges, which are calculated. But you don't have to worry about this, because I created an abstraction for this called ND Audio. And the only thing you have to do is to create a new instance of ND Audio, pass in the reference to the player, and specify the FFT size. So this is doing all the stuff I showed you earlier, but with a lot of, and not so many lines of code, yeah. And if you want to calculate the frequency data, these ranges, you just call the update data function, and then you get the ranges. And you can just use them using the group frequency data property. So the music I'm using is not local. I'm using music from a platform called SoundCloud. They have free music. And they also provide an API, which you can use to get the MP3 stream. And you can use this URL in the HTML audio element. So you can have music, a wide range of music, and you don't have to own it, which is awesome. And yeah, put it in the HTML audio element. So we have some music, but you have seen there are some visualizations in Nerd Disco. And therefore, I'm using the Canvas API. And with the Canvas API, you can draw stuff like a static image, or you can create animations, or you can even do video processing. And this looks like this. When you start with Canvas, you have an HTML Canvas element, which is your drawing space. Then you can get a reference to it. And with this reference, you can get the Canvas context. It's the same thing like the audio context, but for the drawing. And this gives you all the functions of the canvas. And if you want to draw something on it, you can use the context to set maybe a fill style, which is just in color, and call the fill rect function. And this would just draw a rectangle on the canvas at the specific position. But we want animations, right? This would just be a static image. Therefore, I have an update function. And inside this update function, I call clear rect, which just clears the whole canvas. So with every frame, the canvas is cleared, and I have a new frame which has no stuff left from before. Then I can draw something on the canvas and maybe change the position of the rectangle. And I'm using a set timeout to control how much frames per second I have. And inside, I call request animation frame and call the function again, the update function. So I have a recursion, and it calls itself every time. And to start this animation loop, I call just update. OK, so now we have created some animation, in code. But you don't have to worry about the stuff too, because I have created an abstraction for this too, which is called ND visualization. And there you have just created an instance of it and pass in the audio. So the canvas knows what audio is currently processed and can react to this. And the visualization, I also added some kind of queue. And with add element, you can add elements to this visualization queue. For example, the circle, which has some position and the radius and whatever. And the interesting part is the range, because this circle or this element on the canvas only reacts to low-mid frequencies in this case. And only if the frequency value itself is over 245. And this looks like this. You have seen this in my demo. Those circles are 7 different circles, and every circle reacts to a different frequency from low to high. And this creates some kind of animation or visualization. And another element I have is ND Jiffy. And Jiffy is a super awesome GIF archive with lots of awesome GIFs. And they also have an API. So you can call this API and use the data. And they don't only provide the GIFs, but also MP4s, which is better for performance and file size compared to GIF. And I'm using this MP4 in the HTML video element to draw the video on canvas by, whatever I do. And OK. And this might look like this, just in awesome GIF, and you can draw it on canvas if you want. But only because it's a video. So we just looked at the update function again, because I don't want to put all the drawing code of the elements inside the update function. Everything I want to draw on the canvas should be somewhere else. So what I'm doing here is I call the update data function on the audio. So when the update function is called, I get the frequency data of this specific moment in time from the audio that is currently played. Then I call the draw function on the ND visualization, and this goes into these in my element queue and calls the draw function on every element I have in my queue, like the circles or the Jiffy element, and gets drawn on the canvas. And then I call my set timeout and request animation frame to call the update function again. So we have some audio, and we have some visualization. But you also can see I have some LEDs here. So the LEDs I'm using here are from a company called Adafruit, and the product line is called NeoPixel, and the product I'm using is the NeoMatrix. So what I have built here, you can see here, is called the Noob 1, silly name, for my prototype. And it consists out of 5 neometrics on every side, and some cables and a small controller on the back. And as you can see here, one neomatrix consists out of 64 LEDs on a 7 by 7 centimeter surface. But the awesome thing about the NeoPixel is that you can digital address every NeoPixel by itself. So you can set the color of every NeoPixel like you want to be. But let's look at one NeoPixel in particular. So this is just a big image of a NeoPixel. And you can see there's a very tiny driver chip built into every NeoPixel. And this one grabs the data which you send to the whole array of pixels. And every NeoPixel itself consists out of 3 small LEDs. One for red, one for green, and one for blue. And this means we can create any 24-bit RGB color we want, which is super awesome. Oh, no, I don't want to translate. Thank you. So, if we have this neomatrix, and you want to set the colors of it, you can create an array in JS like this. And if we want to set the first NeoPixel to maybe red, we pass in a 3-byte value to this array. And the first value would be red, the second for green, and the third for blue. And this would create or light up the first LED to red. And if we want to set the second LED to maybe yellow, we just pass in another 3-byte value to it. And this goes on for the rest. If you want to set the third one, you just pass in another 3-byte value. So this goes on from the top left to the bottom right, row after row. And you just create a big array of colors and send it somehow to the neomatrix. Yeah, and to send the data to the neomatrix, there's some other product called the Adafruit Fade Candy, which is a very small board. And as you can see, it has 8 inputs, one data and one ground. And every input port can hold up to 64 LEDs. So every panel has a cable into one of those ports of the Fade Candy. And the data gets sent over USB to the Fade Candy board, the array. And what's super awesome about the Fade Candy board too is that it can handle up to 400 frames per second, has color correction, keyframe interpolation, and dithering built in. So you just send the data and it calculates everything itself. And you don't have to worry about the keyframe interpolation and shit. So it's really awesome. But that's not it. If you get a Fade Candy board, you also get some open source software with it, like the Fade Candy server. And the Fade Candy server, you just install it on your system. It runs on every operating system there is, and you don't have to worry about it. And the Fade Candy server is there to send the data you have over USB in a very performant way to the Fade Candy board itself. And another component they provide is the Fade Candy client, which is written in many languages, and one of them is JS, so you can use it on the Node.js server. And the Fade Candy client is there to send data over a socket connection to the Fade Candy server. But you don't have to worry about all of this, you just have to install and use it. Yeah, that's awesome. So, we have a way to send the data to the Fade Candy, but we don't have the connection between the browser and the pixel yet. And therefore, I have written ND-Selector. And ND-Selector, I don't know if you have seen it, or oh, you can't really see it right here. No problem. It's a square on the canvas, and you can move it around, and every selector selects a specific area on the canvas and is one of those neomatrix. So the front one would be this one, and the left one here, right one here, top and back. So every ND-Selector is one neomatrix. But how are the pixels mapped to the neomatrix itself, because you have to somehow map the pixels with the data on the canvas. Let's look at one neopixel in particular. If you have a canvas, it's a huge collection of pixels, like here. It's a small area of pixels. And you could map one neopixel to one pixel, or one LED to one pixel, but the resolution would be very low. So what I'm doing here is I'm selecting a bigger area and create or calculate the average color of this. So in this example, I have a 3 by 3 pixel space, and this would be mapped to one LED. So we look at the update function again. And yeah, we have the audio. We draw something on the canvas. And this is the interesting code to send the data. So this one, the getLEDs function, does all the calculation based on what I select on the canvas using the ND selector. And the connector sendLEDs is just an abstraction for WebSockets, so I don't explain how this works. And yeah, we have the set timeout and the request animation frame. So what we did here, we closed the gap between the browser and our server with a WebSocket connection, which sends or calculates the colors from the canvas in a big array and sends it over WebSocket to the Fade Candy client, which sends it to the Fade Candy server over USB to the noob one. Yeah. And I thought, okay, there's some space left here. Maybe I use another API, because just out of fun. And this was the WebMIDI API. And the WebMIDI API is super cool because you can attach MIDI devices over USB to your notebook without any plugins, and can just use it in the browser. And this works like this. First of all, you have to query the permission from the user, so he gets a nice pop-up and says, okay, yeah, allow that you can use the MIDI device. Then you have to request the access to the specific MIDI device itself, and you get a promise. And if the promise is fulfilled, you get access to the actual MIDI devices that is connected to your PC. And then you can iterate over all the inputs, but the interesting part is the MIDI message. So every time I push a button on this thing, I get a MIDI message or something like this. And I can handle whatever this is. Yeah. So the device I'm using here, oh no, that's wrong. I created an abstraction for this too, which is called NDMIDI. And you just create a new instance and call the connect function, and everything else is handled by NDMIDI. And the device I'm using here is the Korg pad control. And as you can see, there are some buttons. And if I just push one of those buttons, I get the message. And it's like if you listen for events for the keyboard. You have a specific key for every button, so you can map every button to some action if you like. Yeah, those are the buttons. So I will show you what this is. Okay, let me play some else. Okay, back to start. So in the top left, you can see the HTML audio element. I have just styled it a little bit, but it's simply the HTML audio element with nothing else. And those are the selectors. And if I, let me see it. Hello. So this is my MIDI controller, and if I push, oh no, this makes no sense. If I push a button here, Ah, fuck. So if I push a button here like this, you can see I add an element to the canvas, and this element reacts to music. So I can control, like a VJ, what I'm doing here. And yeah, all the other elements are like this too. And those are toggle elements, so if I push it once, they are on the canvas forever. And if another elements are only there if I keep the button pressed. So if I do this, this is there, and if I remove it, the element is left. So, and those are, yeah, those is my demo. Maybe you can see it like this. And if I push, oh no, it's just what I wanted to show you, yeah. This is the front thing, which you can see on the front. And if I move it down here, you can see it's updates in real time. So I can push it anywhere on the canvas, and yeah, you can see it, yeah. Whatever. Yeah. So before I say thank you to all, I want to say or want that you give a warm applause for my cat Katso, because he has had the idea for all of this. He came one day to me and said, "Yeah, Tim, why don't you do this? I mean, you love music." And I said, "Okay, Katso, why not?" And so please give an applause for Katso. Yeah, so everything you just saw, all the software is open source on GitHub. You can do whatever you want with it. And I just want to say thank you for your time and see you.
Thank you, Phil.